Hey, hey everybody. Thank you so much for coming on over because I want to look at this Kubernetes challenge number 19, and wanted to share it with everybody. So yeah, I'm Tabby Sable. I spend a fair amount of time dealing with Kubernetes. I do Kubernetes at my day job. It's got a fabulous community, and it's got really fun, interesting security research going on because it's quite new and we're all still figuring out exactly what the implications of it are. So I made this challenge as a way to help encourage people who had never seen or used Kubernetes before to play with it a little bit. And so it's got a fair amount of like built-in self-hinting, and hopefully it's approachable for somebody that's never used the system before. But we'll walk through it now, and I hope that that will be an interesting experience for everybody. So we see here on the screen, I'm logged into the Try Hack Me page. I've got the task open. I've deployed the VM and got an hour and 48 minutes left on it. So we'll just start by reading out the challenge here. So it says we've provisioned some Kubernetes resources, find them here. And let us know if you find any security issues. So I'm gonna guess there's gonna be some security issues here. So I'll start by downloading this file, and then we'll figure out what to do with it. So I like to make a new directory when I'm working on a CTF challenge and put all of the files into it. So let's go down to the shell here. Is this big enough? Can people read this, or does this need to be made a little bit larger? I'm gonna just look in the directory here and see what this file looks like. Okay, so it's some kind of config file, lists the API version, certificate authority, server name, Kubernetes. What do we got going on here? Thank you. So we'll go in and we'll just start by looking at the hints, because let's assume for the sake of argument that we're all new to this. So we'll look at the hint, and the hint is got a bunch of URLs and stuff here. So I'm going to copy all of this and put it into a file. All right, well, okay, I'll get a copy of kubectl. That's, if you're giving me this link, I'm going to guess this is going to be quite important. So we'll go here and see what this has to say. The Kubernetes command line tool allows you to run commands against Kubernetes clusters. All right, we can deploy applications, inspect resources, view logs. Okay, so we're gonna download the latest release. That looks fine. So this is gonna curl to Google API storage based on the stable release file. Yeah, that looks legit. All right, so here we go. Looks like we got 1 second left, and now we got kubectl. We'll make it executable. And okay, cool. It seems to work. It's got a bunch of commands. All right, cool. What else did we have in our notes here? Here's so here's a link to the Kubernetes documentation. I'm not going to make you all sit and watch me read the Kubernetes documentation, but I will just pull it up on the screen real briefly here in order to how do we list resources, deployments of resources, which manage pod replicas. Okay, so this is all kind of fancy. There's a lot of concepts involved in Kubernetes. So let's talk a little bit about what all these resources in Kubernetes are. So Kubernetes is a system that manages resources, and it does this based on this idea of control theory. So there's a bunch of data structures, and right now, don't worry about what they are. Just think of them as data structures. There's a deployment, replica set, daemon set, pods, containers, all these things. There's arrows on this diagram that show that when you define one of these sorts of things, it's defining directions for the creation of other data structures. And so then there's software inside Kubernetes that is always looking for, oh, is there a deployment that says I should make a replica set? And does the replica set exist? If it doesn't, I better make it. And then a different part of software that's looking for replica sets that are trying to make pods that don't have pods yet. And so the primary thing that you end up doing in Kubernetes is defining these sorts of abstract things that you want to exist, and then letting the system make them for you. And then you have those abstract things defined such that when you finally get down to running containers, then your containers have your applications or whatever you want to have running in them, and then everything works. So let's look a little bit at what all of the software that makes that happen looks like. So Kubernetes came out of work at Google and then later at other very large applications where they have really big scaling problems, tens of thousands of nodes in order to handle very heavy user load. And so Kubernetes has a complicated microservice design so that way each one of the different functions can, be ramped up with numerous copies in order to handle whatever the load is. And so in blue here, we've got this database. It's called etcd. It's a distributed database. It's pretty good at not losing data, even when you have copies of it go away. And it's the only part of the whole Kubernetes system that is stateful. It's the only part of the Kubernetes system that has anything in it you care about. All the magic is inside there. But then to mediate access to that database, the real center of the world here is the API server in green. So every part of Kubernetes talks to the API server, and it's like a really opinionated proxy in front of etcd. So the API server is what you say, hey, I want to make a pod. Hey, I want to make a deployment. You send it an API call that tells it you want to do that. And the API server decides whether you can or not. And if it likes what you want to do, then it goes and it writes some stuff into etcd. Or if you ask it, tell me what exists. Tell me about the pods. If it knows about the pods already, then it just tells you. And otherwise, it goes and says, hey, etcd, tell me about the pods. I'm going to tell this person. And so then it tells you. There's other important parts that you see in almost any Kubernetes installation, and I've drawn these in red here, and they talk to the API server and make the actual magic happen. The API server doesn't really do any of the magic itself. It just provides access to doing the magic. And so the controller manager does most of those control loops that I briefly touched on before. So like, for example, if somehow a deployment definition exists, because you used curl to talk to the API server, or you wrote it directly into etcd with a chisel, for whatever reason, if a deployment exists, then there's a deployment controller that's part of this controller manager that talks to the API server every once in a while and says, hey, is there another deployment? Do I need to make a replica set for it? And if it sees one, it makes one. And then inside the controller manager, there's another loop that's looking for replica sets that don't have pods and so on. So you got all these little happy loops that run inside the controller manager here, each one looking for a certain type of object. And when it sees that object, it does what it's supposed to do. Got the scheduler, which schedules things. So pods are the sort of primary thing that Kubernetes is concerned with, because that's where code really runs. And the scheduler looks for pods that don't have a home and assigns them a home in the form of a node to run on. And then part of Kubernetes that is going to be very important for us today is kubeproxy. So there's fancy networking going on inside Kubernetes. All of the pods have their own IP addresses and so on. And something has to tie all that together and make it so that you can communicate with the applications running inside the pods. That is kubeproxy's job. And we're not going to really use kubeproxy today in as much as we don't need to access any applications, but something that kubeproxy does is going to be really important to our ability to honk inside this Kubernetes cluster later on. And then, of course, users. A system that doesn't have users doesn't do anything, and so users also talk to the API server in order to accomplish their goals. So that picture was what a Kubernetes control plane looks like. There's a very tiny and hard to read version of it here inside this node that's labeled control plane. And Kubernetes is a big distributed system. And what that means is that there are a lot of servers. There are a lot of worker servers that are here to actually do the work. And so the primary thing that runs on them is this last piece of software called the kubelet. And it basically is a daemon that runs as root on the worker node and talks to the API server every now and again and says, you got any work for me? Got any work for me? Got any work for me? And when the all of those control loops have run to completion and resulted in a pod with a scheduling annotation on it that says, run on this node, then eventually the kubelet on that node says, you got work for me? And the API server says, yeah, run this pod, please. And then that's how you end up with happy little containers running inside your worker nodes, doing the things that you actually deployed those servers for. So that's what a cluster looks like in general. So the primary purpose of Kubernetes is you express your feelings in the form of deployments and daemon sets and Kubernetes objects that are in YAML files. And then Kubernetes makes your feelings happen. And your feelings happen in the form of your code running in containers. So just in case folks also don't have experience with containers, we should talk a little bit about containers. So Linux is a Unix-like operating system. It's got processes. It's got a kernel. The processes make syscalls to the kernel to say, write this data to the network for me. Got any network data for me? Please read this block from disk. That sort of thing. And so over here in this kind of first column of this picture is just a normal Linux system, running on some hardware. There's a hypervisor involved there because, we don't have workloads that are so big that we need 56 cores for them. Or if we do, then you can just pretend that the hypervisor isn't there, and then Linux would be sitting right on the hardware. And normally your processes just run inside Linux. But that isn't quite true anymore. Since very, very roughly 10 years ago, a lot of the resource spaces in Linux have been broken up into instances. So, and those instances are called namespaces. So like if you're a process, you're running on a Linux server, one of the most important things about you is your process ID number. It's like the little name tag that the Linux scheduler put on you when you were created and that everybody can use when they need to refer to you, to talk to you, to send you a signal, to log your network traffic, whatever needs to happen with you. And long, long ago, there was only one PID list. And there was only one list of what file systems were mounted where. There was only one list of which network adapters existed and what IP addresses they had. There was only one time. There was only one list of what user accounts existed, all of those sorts of things. But in reality, like the physical reality of the PID of your Linux process is that in the kernel somewhere, there's a linked list of structs, task structs, and one of the fields in a task struct is a PID. And so it wasn't a huge logical leap to say, well, what if there were more than one linked list of task structs? Then we could have a bunch of PIDs, and PID numbers could be repeated. And if you looked at what PIDs existed, you would only see the ones in your linked list. Obviously, the implementation is a lot more complicated than that, but that's essentially what namespaces are. You take these lists that the kernel maintains of its internal data structures, and instead of having one, you make it so that there's a way to make multiples of them. And so containers were built out of these Linux kernel namespaces and some other features so that you can run processes, here these green ones inside the blue boxes, and to those processes, they are living in a fiction that only the other ones inside their container exist. Obviously, they aren't the only ones that exist because there's this one yellow Linux kernel underneath all of these processes, the ones that are in the containers and the ones that are not in the containers. But as long as you don't see the cracks, if you're inside this container, you don't know. All you know is, I've got me and my now 3 friends here. And we're the only things in the world. I don't know why they run this big Linux system for just the 3 of us, because you don't see anybody else. And so this is the essential thing of a container. It's this fiction of having your own system when you really don't have your own system. And this is super handy for developers. This is super handy for sysadmins because you can use this as a way out of config management hell. You can use this as a way out of dependency hell because you can pack up a tar file, and this is what Docker save and Docker build does for you, is it packs up a fancy tar file with all the files and settings that you need to run your application. And then when you actually unpack it onto a space in disk, make a bunch of namespaces, the most important ones usually being a new PID namespace, mount namespace, and network namespace. There are others, but they're not quite as critical to understanding the abstraction. But you make all these namespaces, and then you run your program. Hooray! And your program doesn't realize that any other programs exist. So like if you've got one program that needs Python 3.6 and another one that needs Python 3.7, and for some reason they fight, in the past, it would have been really complicated and annoying to get them to live together on the same Linux system. So we draw this blue box around it, we lie to it, and say, you're the only thing on the system. And then it's happy. So this is what a container is. And because it's self-contained, it has everything that it needs to run. Then if the surrounding parts are all correct, you can just plop one down wherever you want and expect it to work. And that's what Kubernetes ultimately does, is it's this big fancy system here for defining where you want to run containers, how many containers you want to run, and then a fancy system of software that takes your feelings and turns it into specific instructions for machines to deploy containers. And then eventually your machines get the work, they do deploy the containers, and they start running. So this is what we're dealing with. Let's actually get on the keyboard. All right, so we've got this kubeconfig file. We've got this kubectl utility that lets us talk to Kubernetes. And if we just try to run it, let's kubectl get pods. No configuration has been provided. Okay, and so that's why these handy notes are here. So we'll try running this in the way that it's listed here in the notes. Kubeconfig equals diana.kubeconfig kubectl. And now in this case, we have to specify the server we want to talk to because I don't know what the IP address is of the VM that you provisioned. And so since it's hard-coded into the config file, that would be a problem. But fortunately, they gave us this command line option that we can use to just override that. So I'm going to copy the IP address, paste it in here, 6443, because that's the port it's listening on. And then we also have to say insecure, skip, TLS, verify. And the reason for that is because the config file has got TLS certificates in it. And the TLS certificates are good for the IP address that the server had when it was built. I don't know what IP address your server has, so we're just going to we're going to say, don't you worry about it. And, it says version, so let's try that. Let's run version. And it's going to try and talk to our Kubernetes server and see if we get anywhere with it. I expect an answer quicker than this, and I don't know why I'm not getting one. See if something is wrong with my VM. 10.10.774. Can I ping it? Can't ping it. And the reason I can't ping it is because I forgot to get on OpenVPN. So let's go ahead and do that. Get to this little hamburger button, and we're going to say access OpenVPN. Here we go, VPN server US East regular 1, download my file. I'm gonna save it into here. Great. Because it's Linux, I've got OpenVPN installed and it's pretty easy to use. Just like this. This is small, but it's just saying that OpenVPN is working. Peer initialization sequence completed. Cool. Now I'm on OpenVPN. We'll just put that in the background and forget about it. Can I ping the VM? I can ping the VM. Now let's see if we can kubectl version. All right. Okay, so let's see what we actually got here. Client version 1.18.2. Server version 1.18.3. And that's all the hints that we have so far. Okay, so let's remember this version. The server version is 1.18.3. I can tell you that's going to become important later. But all right, so we've got access to use Kubernetes. One thing that I'm going to do to make the typing a little cleaner is I'm going to alias k equals most of this stuff, so that now I can do k version, and it'll just tell me the same thing that we said when we ran the whole big command. So now here we are. We've got Kubernetes access, and the question is, what can we do with it? Well, going back to what we were talking about before, there's a ton of different config objects in Kubernetes. And the main thing that we do with kubectl is manipulate them. So let's look at the help. What can we do with Kubernetes? Looks like we can create or expose or run or set things. We can explain or get some other fancy things that we don't care about right now in this point in our lives. API resources, print the supported API resources on the server. So if you've been using Kubernetes for a while, you already know what most of these are by heart, but we haven't been using Kubernetes for a while, so let's check. API resources. Looks like there's a bunch of different things here. I'm going to temporarily make this smaller so that it doesn't line wrap so bad. Can somebody tell me, is this still readable? Because if it is, I'll just leave it at this size. So these are the different kinds of objects that exist inside the world of Kubernetes on this server. Config maps, those sound like they could be interesting. Namespaces, nodes, pods, secrets, that's going to be cool. Service accounts, flags. DianaInitiative.org flags. That doesn't seem like stock Kubernetes, so I bet flags and hints, I think those are going to have a awesome. Thank you all. I think that these are going to have a lot to do with our success here. Roles, role bindings, cluster role bindings, pod security policies, lots of things here inside Kubernetes. So let's just try getting some things. If we k-get all. All is going to show us a lot of common things you want to care about. And the only thing that it sees is this service called Kubernetes. And just for funsies, let's k-get service Kubernetes. And it gives us exactly the same thing because we're asking for the like very basic human readable what's just printed on the label output. But if we instead say -O for output type YAML, then we get this beautifully formatted YAML, and it tells us all of the things we want to know or we might want to know about this service. What is its IP address? What ports does it use? Things like that. Okay, so kgetAll didn't show us anything very interesting, but there were a couple of things in the API resources list that seemed unusual and related to the CTF. So let's get those. Let's get flags. Can't list flags, so I don't like that. Can I get hints? I can get hints. So before we go and look at some hints, let's do a couple of more sort of stock Kubernetes things. One thing you may want to know if you have gotten access to Kubernetes somehow, in this case by we got a config file, one thing that you will commonly want to know is what are you able to do? And it used to be that you could use auth can I, and then a command like get flags, and it would tell you, are you allowed to do that? No. And so a long time ago, Kubernetes pen testing people would have long shell scripts with loops of, kauth, can I get secrets? Kauth, can I get pods? Kauth, can I all these, for everything like get, create, patch, and for every object type like pods, service accounts, can I get these? But they've bundled that all together for convenience. So now, if we want to know what we can do, we can kauth can I list, and it'll list everything that you can do. So what can we do? It looks like we can do a lot. Can I make it not line wrap? Now this is smaller and it's not line wrapping. Is this still readable? Or is this too small? So these are resources. What can we do? Pods. We can do everything to pods. Services, daemon sets, cron jobs, deployments, secrets, nodes. It looks like we can do an awful lot. So does namespaces appear in here? Oh, remember, let's just try. Oh, yeah, there it is, namespaces. So thank you very much. Let's get namespaces. Kubernetes, the kubectl utility is designed with the fact that people are using it all day at their day jobs in mind. So most things you can abbreviate somehow. So I can also get ns, and it's the same thing. Excuse me for the little bit of a blackout there. So we can get namespaces, and what are the basic commands? kubectl options for list of options. So we'll options and pipe that into more, and that doesn't work, but we'll use a cool trick that I learned the other day. It still doesn't like me. Oh, because it's exactly the size of my screen, so I don't actually need to page it. But the important option that I want to show you here is this one, -n namespace. So if we get namespace, we can see all the namespaces. And let's try doing things in some other namespaces. So we did a k-n default auth can I list, and in the default namespace I can do all these things. But what about the kube system namespace? Sounds cool, and I bet we want to get into there. Can I do anything in there? It looks like I can do a few things, but not nearly as much. So first, let's root around a little bit inside this namespace and see what we can find. Let's review that list of API objects. API resources. So things that were in here that sounded cool. Flags and hints are almost certainly useful because they're a specific thing for Diana Initiative. Other things that you might want to get right away, obviously pods, it'd be interesting to know what's running. In this case, there's nothing running because it's a CTF challenge VM and it doesn't have a realistic setup in it. But secrets is something that we haven't seen yet. Let's see if we can get any secrets. So we got a couple of secrets here. First off, we've got a Kubernetes service account, and then we have a secret called flag1. So I'm interested in that. Well, what does flag1 look like? I mean, it doesn't look like anything because, yeah, we need to look at it. Again, we need to look at it in its detailed YAML format. So here's a bunch of stuff. Another way we can look at it is JSON. In case you prefer JSON over YAML, they're both, ugly and confusing sometimes. But a cool thing about JSON is we can use this lovely tool called JQ, which is like sed for JSON, and we can parse things out on it pretty easily. So like here, for example, if we wanted to get this nicely, we could say JQ data flag, and there's the flag, which is base64 encoded because Kubernetes secrets can contain arbitrary binary garbage, and you need a safe way to serialize that into YAML or JSON, and base64 is a good way to do that. So I'm not going to tell you the flag, but if you're following along, you can get it from here. But let's look at the message. So here's our message, and let's figure out what our message says. Can you kubectl get any hints? All right, so let's kubectl get hints. And also, congratulations us, we got the first flag. It was right there in the secrets, because if you have inappropriate access to a Kubernetes cluster because you're pen testing it and you have very little time, one of the first things you might be interested in is the secrets. So there's a secret, it's got your flag in it. So if we get hints -o JSON, this will give us all of our hints. But again, this is hard to read, so let's do some JQ magic on it. It looks like there's a top-level array called items, and then inside items, there's spec and message. So we can pipe this to JQ.items, and if you pass empty square brackets, it means iterate over everything in this array. Spec message. So here's all of our hints. It's a bad idea to enable the insecure kube API server port, but that's the default. A lot of clusters have it. kubectl version could be really helpful right now. Have there been any Kubernetes CVEs published lately with a proof of concept? The K8s host is isolated from the internet, but container images for Ubuntu, Alpine, BusyBox, and TDI CTF Toolbox 1.0.0 are already loaded in case you need them. So we're probably going to need them, or the hint wouldn't be here. So let's try and follow along with this hint. It's a bad idea to enable the insecure kube API server port, but that's the default. Well, what is the insecure kube API server port? And it looks like Google is doing the work for me, controlling access to the Kubernetes API. That sounds interesting. By default, the API server serves HTTP on 2 ports. The localhost port is intended for testing and bootstrap. No TLS, bypasses authentication and authorization. Default is port 8080, and it's protected by the need to have host access. And the secure port, used whenever possible. Default is 6443. So we've been using the secure port, but it looks like the localhost port is on by default, and it should be turned off, but a lot of clusters have it on anyway. And now kubectl version could be really helpful right now. So we'll do that again. K version, and the server version is 1.18.3. So have there been any Kubernetes CVEs published lately? Let's look into that. Do we have any Kubernetes CVEs? I really want to not pull up the MITRE page because it's always so slow, but so it actually looks like there are a bunch of Kubernetes CVEs, and this one mentions 1.18.3. The kubelet and kubeproxy components were found to contain a security issue which allows adjacent hosts to reach TCP services bound to 127.0.0.1. This is going to be pretty interesting. Does this have some good links on it? Okay, here's a couple of links to Kubernetes issues. Kubernetes issues on GitHub usually have great information. Node setting allows neighboring hosts to bypass localhost boundary. In clusters where API server and secure port has been disabled, this is a big deal, it says. And I'm going to apply some of my own editorial here. I think that this can be a big deal on any cluster because it depends on what you have running on localhost. But according to the hints here, I think the API server and secure port is probably running on localhost, and that's bad. So, all right. Is there a proof of concept for this? So we can just search Google CVE 2020-558 proof of concept. And, you know, of course, the jig is up. There is a proof of concept because I wrote a proof of concept. And so it seems pretty likely that we can use this tool in order to access the API server and secure port. So let's try that. I really recommend actually reading the write-up here. And also, I want to say it's not a great idea to just download and run exploit code without looking at it, because occasionally it's actually bad. There's a particularly famous exploit for SSH on Red Hat Enterprise Linux 5, I think. And it's got a bunch of impressive looking hexadecimal code. And it claims that if you run it as root, then it will do something to the SSH port and give you a root shell on the remote server. But if you actually read all of the fancy hexadecimal code, it's just a very obfuscated rm-rf/. And so if you run it, it tells you got to run me as root. And if you run it as root, then it erases your computer and you cry. So it's cool to search for attack code written by weird women on the internet, but it's very important to actually read it. And you may not understand all of the details, but at least sniff it and make sure that you're not making a fool of yourself. So here's this exploit code, and it doesn't seem to be doing anything weird to your host. In this case, like, I am the author, and I promise you it's not doing anything weird to your host. So before we go and actually try and run this on the cluster that's there inside of TryHackMe, I want to take a moment to talk about this a little bit. So in like traditional network pen testing, you are usually looking for bad configurations or out-of-date versions of software. You have a ton of software that's written in C that has memory handling problems. And so like back in the 90s, if there was a buffer that got more data read into it than its length, you could just write shellcode into that thing and go to town, execute whatever code you wanted, and you're great. And of course, over the last 20, 30 years since the 90s, there's been this eternal cat and mouse game between things to make memory corruption vulnerabilities harder to exploit and new ways to exploit memory corruption vulnerabilities. But it's still sort of this default way of thinking about doing network penetration testing is, I'm going to hop on the network, I'm going to scan for bad software, I'm going to pew some packets at the bad software, I'm going to catch all the shells and win the game. And Kubernetes doesn't really lend itself to being treated that way. The biggest reason for that is because it's all carefully written in Go. And so there are Kubernetes bugs, but it's shockingly rare to have a bug in a Go app such that you can send it weird-looking hex characters and it coughs up a shell. To do that would require a really deep bug in the Go runtime, or for the developers to be making extensive uses of unsafe language features like the unsafe package and CGO. Those things in principle can happen in a Go application, but in practice they're wickedly, wickedly rare. And so we're not going to be able to hack Kubernetes like that, asterisk. I mean, it's potentially possible, but that's not historically how things work. This is not all Kubernetes things, but there are also historically not a ton of Kubernetes vulnerabilities that get released because, again, the majority of vulnerabilities in the majority of software are memory handling vulnerabilities. And because Kubernetes is in Go, it automatically gets a lot of hardening against that sort of thing because Go tries to be a memory safe language. So generally, you have to deal with Kubernetes as it is. But fortunately for you, as an attacker, it's wickedly complicated. If we go back to here, Kubernetes this is like the minimum viable architecture diagram. And it's already pretty complicated. And so now we go and run that on a bunch of hosts. And then we think about what's actually inside all those hosts. There's a ton of attack surface. There is so much code running here. And so there are so many possibilities for misconfigurations. There's so many possibilities for logic bugs. So we are not generally going to be able to just slam the door in and run code. But if we understand Kubernetes and we think about it the way that the developers think about it the way the sysops think about it, but find mistakes that they've made. Find access control policies that are overly broad. Find the occasional bug. So in this particular CTF challenge, it looks like with the system being 1.18.3 and there being this high severity CVE against 1.18.3, it looks like we can probably just download the exploit and run it. But that's not the usual way. But I wanted you to get a feeling of what it's like when you can do that. To me, it feels a little bit like, to make a lockpicking analogy, being able to do this feels a little bit to me like using a wave rake and popping a lock open. It frequently doesn't work, especially if the lock is good, but sometimes it works, and when it does work, it feels like cheating. It feels like magic. But most of the time, you have to very carefully single pin pick the lock, and in Kubernetes, you usually have to carefully examine the configuration and find mistakes that the system operators didn't find. So in this case, we've got it easy. There's this vulnerability, and we're going to exploit it. How are we going to exploit it? So one thing that we could try is downloading and running this Python code locally. And I'm going to save you the trouble. Don't waste your time, because this Python code, we can read it. This Python code depends on forging the IP addresses and MAC addresses of packets. And we don't have layer 2 connectivity between our OpenVPN machine here and the VM that's up in TryHackMe, so we ain't going to be able to do it. Just get this pretty picture here for us. Come on, where's the picture? Okay, here we go. So, data link layer between two nodes connected on a physical layer. We're not connected on a physical layer. We are going between modes in a multi-mode network, and so we can't do layer 2 shenanigans from here to there. I had hoped that you would be able to do layer 2 shenanigans between the Kali Linux box provided by TryHackMe and the challenge VM, but you can't do that either. And the reason for that is because it's all running in AWS. And in AWS, the layer 2 between VMs is completely fake, it's completely opinionated, and it only passes traffic that makes sense. So you can go ahead and, if you're a subscriber, plop out the Kali Linux VM and try it, but you will find that it won't work because the AWS networking substrate is going to smack down all of your weird packets. So that ain't going to work. But we do have access to one computer that is local to the machine that we're trying to get access to, the machine itself. So let's see if we can run a pod. That's the whole point of Kubernetes, right? Is to run a pod. So we can just run a pod. If we go back to our hints, Ubuntu, Alpine, BusyBox, and TDI CTF toolbox are already loaded. So let's just try running them. There's a kubectl run command for that. And so we'll just do it. We will do kubectl run, and we need to give a name to it. And so let's call it going to fail, because this is going to fail. -image Ubuntu. And if you're familiar with Docker, there are some command line options you can pass. So -I means that you want to get input into it. -T means you want to allocate a TTY. We'll pass -rm so that it gets deleted when we're done using it. And then the command that we want to run inside this Ubuntu image is bash. So we will try this. And a DNS subdomain must consist of lowercase alphanumeric characters, dash or underscore. Okay, fine. It doesn't like my name. Gonna like this name. I think so. Chugga, 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 chugga. This ain't doing what we want. This is supposed to give us a shell in a container. It's not happening. So why is that? We tried to make a pod because kubectl run is like a shorthand around creating a pod and attaching to it. So what do we have for pods? Error image pull. Well, let's inspect that. And right now, the word that I'm looking for is slipping out of my mind. Describe. Describe it to me. Failed to pull image Ubuntu, can't connect to Docker registry. And the reason it can't connect to the Docker registry is because the Kubernetes node is isolated from the internet. This gets into a detailed thing in Kubernetes called image pull policy. And you can say, pull this, pull down this image of this container every time I try to run it, versus only pull it down if it's there. So we could, we could pass in an override to say image pull policy if not present. And I think this is how it works. No, let's just look it up again. Dash is in it. So we'll put the dashes in. Pod already exists. But my pod that exists is broken. Let's delete it. Bye, pod. Let's try this again. You don't see a command prompt, try. Hey, look at this! And I'm root. I can do whatever I want, right? This doesn't have very much installed in it. I can't really do whatever I want. This is not nearly as cool as I wanted. To help solve this problem, this is why I gave us this this toolbox pod, because it's got a ton of stuff that you might want loaded into it. So let's run that one instead. And because this one is specifying a version number, Kubernetes will default to not downloading it if it's already there. our pod. And here's my problem again, where it has to be lowercase. I'm going to call it our pod. This is taking a lot longer to start up because this pod image is huge. It's like 800 megabytes. But now here we are. We're on our pod. We've got an IP address. We have ping. We don't have ping. So now we're here inside a pod. And one thing that's neat about Kubernetes is that a pod automatically has stuff defined in it, like how to talk to the Kubernetes API. There's a bit of an errata about this challenge VM, which is that this access to the Kubernetes API through the Kubernetes service doesn't work because there is a part of the kubeproxy config that I failed to update when I re-IP'd the thing. But the good news is it doesn't affect the solution to the challenge. But if you wanted to try and crawl around inside Kubernetes from in this pod, it would confuse you. So we can fix that in the same way that we did on our host by doing server equals and the IP address of our server. But let's try talking down the Docker port instead to the host. So let's guess 203.0113.16443 insecure skip TLS verify. Version. Please enter username. I don't know. Oh, but it works. Look, we can talk to Kubernetes from inside the pod too. Cool. The reason for that, if we look at the mount table, oh, that's a lot. Reason for that is because of this tempfs here. Run secrets, kubernetes.io, service account that has all of the same information in it that would be in our kubeconfig file. So therefore, we can talk to Kubernetes. But can we do anything cool? No, we can't even see what we're allowed to do because we're anonymous and the system has decent configuration. Anonymous accounts aren't allowed to do anything. Because if they were, then they would. People would do bad things. We don't want people to do bad things. So let's get ready to do some bad things. We're on this pod. The pod can talk to the node. We know that the node probably has this vulnerability in it. Let's go. POC 2020.5.py. Going to go into insert mode. Going to go get this code, going to see the raw version, select all, copy, paste, save. Just for convenience, we're going to chmod it and run it and see what it tells us to do. Come on, AWS, I believe in you. Okay, usage, this script, -help if we want, -h if we want help, -- fake destination, target. Okay, let's look at the help message. Quote unquote proxy for CVE 2020-8558. Read the write-up if you want to understand why there's scare quotes around the word proxy. Target, vulnerable host on which to access localhost services. An arbitrary unresponsive IP address defaults to 198.50.101. Okay, so back when we were looking at the code for this thing, we saw that it is taking packets that are trying to go to localhost and duplicating them to fake destination, and taking packets from fake destination and duplicating them to look like they came from localhost. So that means if we run this script with the IP address of the server, and I don't remember what that was, so I'm going to look at it. Our IP address is 203.0.113.12, so I guessed that the host was 203.0.113.1. So we'll pass that in as the target, and we'll run it in the background so that we can still have our shell. So now if this is working, we should be able to talk to the port 8080 API server. Let's try that with Netcat. 198.51.101 on 8080. And if this is working, then that script running in the background is going to flip around and redirect our packets for us. So can we get? Oh, we're talking to it. So CTL server 198.51.101 port 8080 HTTP auth can I list auto. That's my typo. Yes, this is the best thing that you can see. All resources, all verbs, everywhere. So now we can do all those things that we wanted to do before but couldn't, such as at flags. I want to look in all namespaces. There's a handy option for that, -A. You probably don't want to do that in production very often, because if you're on a big cluster, all of your namespaces are going to contain a lot of things. But well, why don't you love me? Can we get pods? We have to put the -A later. I'll put the -A later. So there's all of our pods in all our namespaces. Notice our pod, which is the one that we're in, and the rest are all in kube system. And here is the scheduler, proxy, controller manager, API server, and etcd that we talked about before. And then a couple of others, core DNS, that make sure that the various pods can talk to each other. So now we get flags. Here we go. Here's a flag called bonus1. So we'll look in the kube public namespace directly, -o YAML, and that's a flag. Now, what else? There was a secret before. So there's probably more secrets now that we have access to all the namespaces because we're admin. Let's look at the secrets in all namespaces. There's a lot. But here in kube system, which is accessible only to the sysadmin, there's another flag. So we can get that one. Kube system flag 2 -o YAML, and here it is. There's a flag and a secret message. Do we have base 64 inside here? Of course we do. Messages, nice work. Now keep going. Get to the root of the matter. So we go back up and we pay attention to the scoreboard here. We can see that we have got use the provided credentials to access the Kubernetes cluster and find the first flag. We've done it. Become the admin and find the second flag somewhere inside. Here was a hint in case you needed it, because it would tell you to find the hints. We found the hints, we followed the hints, we became the admin, we found the second flag. We also got the bonus flag from Kubernetes. Now we need to escape to root on the host and find the third flag. And now this is where this discussion about containers becomes really relevant again. Remember I said that this blue box here that is the container was a total fiction? It's super a fiction. It's just a bunch of lies that you tell to these processes in here that nobody else exists. No other PIDs exist, no other file systems exist, no other network connections exist. But it's not true, it's a lie. And so if you can break the lie, then you can find out the truth, which is that other processes exist and so on. And there are several different ways to escape from a container. If you want to learn more about that, there was a talk at Black Hat some time ago, which was spectacular, called a compendium of container escapes. And I'm going to try to put that link into the chat here. If you want to learn about container escapes, you can watch that video. It'll teach you a lot about container escapes. The primary ways of escaping a container come down to either configuring the container so that it doesn't really contain anything, or exploiting some kernel bug that lets you do things outside of your container. So like, for example, if you had a remote code execution, if you had a code execution vulnerability inside the Linux kernel, then you could run code in the kernel and hop out of your container. Or I said that this is complicated. There's a ton of kernel features, and sometimes a kernel feature can be accidentally made allowed inside a container that allows you to affect the world outside the container. And if you can do that in a clever way, sometimes you can escape the container. So the video has great information about that, but we are the great and powerful administrator, so we can do whatever we want. And what we want is to deploy a container that just doesn't contain in the first place. Back in November, back when we used to travel, me and several other wonderful co-conspirators gave a workshop at KubeCon that walked through a bunch of attacks and how to defend against them. I've posted the link to that in the chat as well. And there's a great copy pasta in here that gives you a pod. Shout out to Duffy Cooley, who made this wonderful tweet that we were able to just insert directly into the workshop with his blessing. Thank you. So we're going to copy this and we're going to paste it down here into our shell. And I need to, oh, this ain't going to work because we also need to pass all of those options for server. So I'm going to type these in, and then I'm going to unpack what this big pile of fanciness does and why it's going to give us a shell on the host. All right, so we're going to kubectl run root. I am going to call it honk. Shout out to the sig honk people. Restart never. -T in order to get a terminal inside the pod, -I for having our standard input connected to it, -RM for deleting it when we're done, --image, LOL, because you can't kubectl run without specifying an image. And then here's where the fancy stuff comes from, --overrides. And so this lets you just cram specific JSON configuration directly into the fake pod that it's going to make for you. And here's what we're specifying. Host PID true. So when we go back here, one of the key lies that you tell to a container to make it contain is that it's the only PIDs in the world. So if we instead let this one share the PID namespace with the host, then this container will be able to see all the processes. Now we specify the Alpine image, and the command that we're going to run inside that Alpine image is nsenter, which is one of these low-level Linux commands to manipulate namespaces. We want to run a process in a namespace. The process that we want to run is bin bash, and the namespace that we want to enter is the mount namespace of PID1. PID1 is the primordial process. It's init. On modern Ubuntu versions, it's systemd. And we know that PID1 always exists, because if it doesn't, the kernel panics. So we're in the host PID namespace, which means we can see all the processes. And we know that PID1 always exists. And we know that PID1 has to be in all of the other host namespaces, or it couldn't work right. So we're going to enter into its mount namespace. And so when we get this shell, it's going to see all of the processes, because we wiped out the PID namespace separation. And it's going to see all of the host files, because we wiped out the mount namespace separation using this nsenter command. It will still see its own network connections it won't see the host's network connections. We could do something about that if we needed to, but we won't need to. We'll have plenty of access just by doing this. And the last part that's the critical piece here is security context privileged. Privileged is like the danger flag in all of these container things, because if you have a container and you tell all of these important lies about what PIDs exist, what mounts exist, and so on, it is pretty strong as long as you don't have the ability to call dangerous things. And if a process is properly locked down into its namespaces, which is a thing that you can do by setting a bunch of flags, some of which are default and some of which are not. But there's a great upstream Kubernetes page about this called Pod Security Standards. And I'm going to link that in the chat as well. If you set a ton of settings, some of which are defaults and some of which are not, then the isolation provided by a container is actually pretty solid. It's not 100% waterproof because of this, if I can get code execution in the kernel, it's party time thing, but it's pretty good. But if you start to give more privileges to the process, then you start to expose more dangerous kernel features. You start to greatly increase the chance that the container will leak and the processes can get out. So when you run a container with security context privileged, that means let it do whatever it wants. And that's why we can say nsenter to enter this other mount namespace. We couldn't do that if we were privileged. And in fact, let's prove that. I'm going to get out of this hunk pod, and I am going to... No, I'm not going to do this because I don't want to go into YAML hell, JSON hell of trying to get all the curly braces and stuff matched up. You just have to take my word for it. Oh, no, we can just make this false. Okay, so we're going to run this as false, and we're going to get smacked on the nsenter. Nsenter can't open proc1 ns mount, permission denied. Pod deleted, pod terminated. But if we're privileged, our nsenter can work. And looky, we're now on the host. Do we really believe it? Let's see, what's the host name? Well, the host name is actually part of the UTS namespace, Unix time sharing system. And we didn't do anything to escape our UTS namespace, so we still think that we're here. But if we go into /etc cat shadow, all right, I believe it. If we run ps-ef, we can see all of these processes like kube scheduler, API server, containerd, shim. We're certainly on the host here. So going back, what is our actual goal again here? We are trying to escape to root and find the third flag. I mean, this is a CTF, so the first thing that you want to do is there flag.txt in root's home directory. Yeah, there is. So I'm gonna tease you a little bit. We cat the flag, then we can go and capture it. So, all right, we got that, and let's see if we can find the bonus flag. Okay, so let's pretend we're attackers. We just got root on this host. We want to get some loot. We got to know what the host is doing. Yes, I can enlarge the font. Let's make the font a little bigger. Let me know if that's better for you. So yeah, here we are. We're on the host. We've capped the third flag. We want to look for the bonus flag. So what does this host do? Well, we know it's a Kubernetes host. So there are some things that we could do, like we could inspect the containers that are running. We can already do that, though, because we're Kubernetes admin. So it would be more convenient to do that through Kubernetes. What could be special about this particular host? One thing that could be interesting could be cloud provider metadata. So let's see if we can curl this Most cloud providers have a metadata server that runs on 169.254, 169.254. This is not loving us, and the reason for that is that if we could access this, what we would be learning is information about TryHackMe's AWS account. They don't want us to learn this stuff because then we could, potentially use it to attack their cloud account, and that's out of scope. So I'm doing this because I know that it's blocked. But in a real attack, this would be one of the first things you would do is start crawling around, hoping that you can find cloud metadata server. Look on the host, see what IP address. Look in the ARP cache, what host is it connected to. Look in netstat. See who is it talking to. There's really not a lot going on this thing. But maybe something has been done on it recently. So what's root been up to? It's in root's home directory. Root's probably got good things in their home directory. We'll do ls-l for long, A for all, R for reverse sort, and T for sort by time. And here's roots.bash history file. Maybe roots run some cool commands. In fact, root has run some cool commands, and that's where the bonus flag is. Because oftentimes, if you are on a server, either as a forensic person, like what is this server for, what's it doing, or as an attacker, you can go and read root's history file and just get some idea of what people have been doing on the server. And it's not uncommon for people to accidentally type passwords in. It's not uncommon for people to run administrative commands that require passing credentials on the command line. And sometimes that stuff gets logged into root's history file, and you can get loot out of it. So this is a simulation of that because bonus flag is in root's bash history file. So that's a walkthrough of this whole machine with a lot of backstory that I hope will make it interesting to go learn more about Kubernetes, learn more about offensive techniques, understand better the sorts of things that your attackers could do, understand better what makes your systems work, because ultimately the essence of security, to me, comes down to the difference between the ideal, how a system is designed to work, and the real, how it actually works, and finding ways that you can creatively use that difference to your advantage. So like in this case, one thing that was a problem is there was this bug in Kubernetes, CVE 2020-8558, and it didn't work the way it was supposed to. The services running on localhost were available to us. Another problem is this system administrator configured this bad idea feature of an insecure port. And with those two problems combined, we were able to go from a relatively locked down, low privilege Kubernetes user to full Kubernetes access. And since Kubernetes, when we go back to it, is a system for asking machines to do work, once we had full Kubernetes access, we could ask the machines to do whatever we wanted. So we did it, and I hope that it was fun. Reach out to me. I'm going to be hanging out in the CTF channel for a while. Reach out to me if you have questions. I'm on Twitter, Tabby Sable. At me. Say nice things. Say mean things if you really have to, but why be that way? But anyway, I hope you had fun. Enjoy the rest of Diana Initiative, and go cap some flags.